Some set of programs is called a software. For example, let us take a bank software. It contains a number of programs like to open a bank account, to give some information. That information like what is your name, address, what type of account you are opening with, what is the minimum balance. Like this, you are providing some information. That information is processed and the account is open. That is one type of program. Once the account is open, and from next stage onwards, you can do some transactions like withdraw and deposit. For this, another program is created. Or if you want to transfer the amount from one account to another account, there is another program. Like this, some set of programs, you can call it as a bank software. So what is a program? Program is nothing but some set of instructions is called a program. Some set of instructions is called a program. That means already told, in case of while opening the account, you are giving some information like what is the name, what is the address, what type of account you want to open, and with what balance. Like this, you give some information. That information has to be processed with the help of instructions which is given by user, nothing but developer. So some set of instructions is called a program. And this software is categorized into two. One is the system software and the next one is the application software. System software is nothing but the operating system. Application software is nothing but the general applications, also called the commercial applications. For example, banking software, sales software, and telephone billing system, etc. So operating system is an interface between user and computer. Operating system is categorized into two. One is a single user operating system and the next one is a multi-user operating system. The difference between these two is, in case of single user operating system, the resources cannot be shared. Resources like file, printer are not shared from one system to another system. In case of multi-user, it can. That means the resources can be shared. Example for single user operating system is a DOS, a disk operating system, and example for multi-user is a Windows, Linux, Unix, and then Sun Solaris. And the next question comes to the picture is how these operating systems are developed and how the application software is developed. Operating systems are developed by using languages. Application software is developed by using packages. Languages as well as packages. Here two points comes into the picture. One is a language and the next one is a package. So here the difference between language and package is, in case of languages, to perform particular task you have to write your own instructions. For example, here I am giving some information. What's my requirement is, example, accept two numbers and display sum of those. So generally English statements are written. This is called a pseudocode. Based on the problem definition, you can declare what are the variables. After that, you can accept the input and do some process. According to the problem definition, the process is addition of two numbers so that you can display n1 plus n2. Once the process is over, you can stop the process by using the keyword stop. This is a general English like statement. It's called a pseudocode. Same thing you can implement in languages. Based on the language rules and regulations, you can use certain keywords. Whereas in case of packages, you can use some predefined commands as well as the tools for the same purpose. That means for adding two numbers, you can use the calculator. That means if there is no chance to use predefined commands as well as tools, that is called purely language. If there is no chance to write a program, that is called purely package. Example, MS Office. And some software having both the features, those are called languages as well as packages. Example, .NET Visual Basic Developer 2000. And come to the next point. Languages are categorized into two. One is the structure oriented language and the next one is object oriented language. The difference between structure oriented and object oriented is, in case of structure oriented language, there is no concept of reusability. with respect to the attributes. That means whatever the attributes you are defining in one structure is not possible to use in another structure. For example, let us take in a single program I want to maintain three different person details. One is the student and the next one is employee. All these three different persons having their own attributes. In case of student, I am talking about roll number, name as well as a class and then few details. In case of employee, employee ID, employee name, job and then salary. In case of customer, customer co-ID, customer name, credit limit and then credit balance. Up to this, definitely have to declare separate variables. But all these three different persons have a common attribute that is called the address. Address is a combination of different attributes like house number, street, city, state, pin code. Let us take where this information is stored. If it is a temporary, it's stored in RAM. If it is a permanent, stored in hard disk. Anywhere the information is stored, we have to measure that in the form of bytes. Let us take you are allocating for address some 250 bytes. So what is the drawback in case of structure oriented languages? Whatever the attributes you are defining for address in the student structure is not possible to use in a employee as well as a customer. Again you have to redeclare. Because of this redeclaration, what happened? Number of bytes are wasted and the performance comes down. So example for a structure oriented language is a C language. To overcome this above problem, we can use object oriented languages by using the concept inheritance. So examples for object oriented language: C++, Java, Python and C#. Like this you have different languages. And the next point talking about this algorithm. Algorithm is nothing but somebody said that simple definition. The logic behind the program is called an algorithm. And in colleges they said that step-by-step procedure to solve a problem. Suppose if it is a step-by-step procedure to solve a problem, keep on if you are writing the instructions, there is no terminations, then is it called an algorithm? No. So that the main definition or proper definition is, it is a finite set of instructions in which each and every instruction has a meaning, and instructions are not ambiguous. Meaning in the sense it will generate some output, ambiguous in the sense repeated, not repeated, and all the instructions has to be executed within the finite amount of time. Everything is a finite. The finite keyword is the most important while giving the definition for an algorithm. And while designing an algorithm, there is a certain criteria for this. Input is optional, whereas output is a must. So in what type of programs input is a must? In the sense, if the problem definition contains the keyword accept, definitely there must be input. For example, accept a number and check whether the number is even number or not, or odd. So in this case, what happened? The problem definition contains the keyword accept, that's why there must be input. Same even number program somewhat changed like this. Display the even numbers between 1 and 10. So in the problem definition itself, the starting number is given and the ending number is given. There is no input, but the output must be there. It will display the even numbers between 1 and 10. For any program, we can think in such a way. So there are 4 points you have to identify. The first most important part is how many variables are required for this program. Is there any guarantee all the programs require same number of variables? No. Is it possible to by heart the program? No. In this case, you go through the problem definition number of times, twice or thrice or n number of times you can go through. You can identify how many variables are required this problem. After identifying this number of variables are required, the next point is out of n number of variables, how many variables needs an input and needs to initialize. In general, some of the variables are accepted and some of the variables has to be initialized to 0, or some of the variables can be initialized to some value. That depends on the problem. And third point is What are the variables used in process? Mostly can use all the variables. If are not use any variable in the process, no need to declare that variable. And third point is on what variable base the output is displayed. So these are the 4 points you must remember. And algorithms you can represent in two formats: graphical format, it's nothing but flowchart, and English like statements, it's nothing but pseudocode.